I just wanted to take a moment here in 7.1 to talk about how to solve some of these problems in Excel. So I've got a couple of the handouts posted here. This is let's see, I should probably show you the first page. The first page, this is the transportation problem notes. And if you scroll down for a little bit there, you'll see a power distribution problem. And that's the one we're thinking about. So we have 3 electric power plants, 1, 2, and 3. Then we have 4 cities, A, B, C, and D. And see table 1 for the amount of power available to each city. And so see here we see power plants 1, 2, and 3. They can supply 35, 50, and 40 kilowatt hours. Then our cities A, B, C, and D. Okay, and so these are some of our costs for sending 1 million kilowatt hours from the plant to the city. Okay, now putting this into a tableau would look something like the following. And notice that in this tableau we have 125 million kilowatt hours we're able to send out, and the demand is also 125. Okay, and you see your costs here in the corners. And what I've done here is I've just went ahead and filled in I just kind of did a sample distribution. So the blanks would have the 0 being sent, and then you see that we're matching up all of our demands going down, and then across we're also matching our supplies. So this is a nice balanced problem with a specific cost here, and we want to just try to use Excel now to try to solve this problem. So if you go to 7.1 handouts.pdf, you'll see a brief little description of how to do this. I've got the Excel sheet on the class website, so you might go ahead and download that. And so let's just go ahead and take a look. You can see that in this area here, I'm going to save this array for all my costs, and I gotta have a second array to these are going to be my decision variables are stored, right? And so I'm going to be putting in my decision variables here. I want to check to see how much each column sum or row sum is, and I want to check that against my supply, and then I also need to compute the column sums and check those against demands, right? Okay, so that's kind of the structure of what's happening here. So in this top array up here, these are just the numbers associated with each of the costs. Okay, and then down here, these are my decision variables. And so you'll notice here, these are just all blank in here right now. And so if I go here to total sent, you can see that the sum is here, D12. This must be D12 here, to G12, which is here. Okay, and so on. So these are all the formulas that are already written here, so you can see those. Good. And so this is being my total cost all the way down here. Okay, and so this is the amount that I'm trying to minimize, right? This is cell J17. I want to minimize my total cost. And what do I want to, what does that depend on? That depends on these variables right here. So if I go to my solver, my linear solver, my target cell is J17. I want to minimize that by changing cells. Which ones? All of these right here. Okay, so that automatically put those in for us. And now when I do my constraints, right, I just have to look at these cells and compare them to my supply cells, or these cells, and compare them to these. So I need H12. I want to be greater than or equal to 35. So I can put that in, and then H13. I don't really need dollar signs on there, but I'm just going to go ahead and leave them on there. 30. Let's see, that was 50. Then we have I guess I could just use the cells too. Oh well. H 14 greater than or equal to, and again I could just say J14. Oh, I guess these are values. That's fine. 40. Okay. And then we come into our demands. Let's see. Which one is bigger? Do I want my, I need this to be the other way around, right? Sorry about that. It's starting to get late in the evening. Okay, so in this case we have D15 greater than or equal to 45. D15 greater than or equal to 45. Okay, then we have, scroll down, scroll down, scroll down, scroll down, D15. Okay, now we have E15 greater than, and again you don't need dollar signs. I don't know why I keep doing that. Habit, I guess. And then F15 greater than or equal to 30. And in fact, these could be equal signs if you really wanted to get down to it. G15 greater than or equal to 30. Okay, good. And then remember to hit the options because we want our variables. We don't need to assume the variables are integers, but we do need them to be assumed to be non-negative. Okay, and then we solve. Ta-da! Beautiful. Keep our result. And we see here what our distributions are, and we see that everything is equal signs, equal signs, equal signs. Very good. And so this is how you solve the power company problem. And so you would do a very similar technique for any of these transportation problems. Good. All right, I'll stop it there, and I'll let you work on the homework.